everybody, and welcome back to another STEM video. Today we're going to do a video about how animals that live in the Arctic and the Antarctic, like penguins, polar bears, and seals, stay warm when their environment is so cold. Animals need to stay warm because if their bodies get too cold, their organs won't be able to work properly. It's really important that an animal's internal temperature, which means the temperature on the inside of their body, is always pretty much the same. So to do this experiment, we've got two materials plus one secret mystery material that you guys can help figure out. So first I just have some paper towel to clean up, and I have a bowl here, and in the bowl I've put really cold water. You can even put ice cubes if you want. So first thing you're going to do is dip your hand in the cold water. So as you can see, you're going to feel that it's really cold and your hand is going to get wet. Now, part of the reason that animals that live in the water often have way more ways to keep warm than animals that live on land is that water is often colder than land. And the reason is because of something called specific heat capacity. So if you haven't heard that word, let's explain it. When you add heat to something, so let's say I put this on the stove and heated it up, or I poured hot water into it, it would get hotter. Depending on what material it is, in this case it's water, but it could be anything, it's going to heat up a different amount. So for example, if you take a bowl of water and a bowl of oil and you heat them both up and you add the same amount of heat, the oil will actually end up hotter faster than the water. It's really hard to heat water. And that's why even when the sun's really bright, it's really summery, you go to the beach and it's so hot and you get in the water and the lake is freezing. And it's because the heat from the sun will eventually heat up the water, but it takes a really long time. This idea that some things heat up faster or slower than others is called specific heat capacity. If something has a low specific heat capacity, it means that it will get hotter faster. If something has a high heat capacity, that means that it will take a lot more energy to get hot and it's more likely to be colder. So water has a very high specific heat capacity, and that means that the oceans are usually extremely cold. That means that animals that swim in the ocean are usually swimming in pretty cold water. It's also important to know that when you get water on your body, whether you're a person or a polar bear or a penguin, that water is going to take heat away from your body, and it's going to be harder for your body to heat that water back up. That's why when you get out of the bath or the pool or the lake and you go on the beach, even though it's really hot outside, you usually feel a little bit chilly. It's because your body's trying to heat up that water to the same temperature as your body is on the inside, but it's really hard because remember, it's really hard to heat up water. So if you're a penguin and you're swimming around in the ocean and it's freezing cold, you want to do something to keep yourself warm. There's different ways that penguins do this, but there's one that specifically relates to keeping the water out. So you know that water will make you colder because of its high specific heat capacity. So here comes the challenge part. Can you take a guess at what penguins use to keep water away from their bodies so that they don't get cold? I'll give you a hint. The answer is somewhere else in one of our other STEM videos. So you can go watch those videos and see if you can find the answer. A hint is that you want something that's going to repel the water. So what could a penguin use that we've talked about in another video that's going to repel the water? See if you can take a guess. Have you made a guess? Well, I'll tell you, the answer is oil. That's right, penguins use oil to keep water away from their bodies. Remember, we talked about how oil is hydrophobic and water is hydrophilic and how they don't mix. If you don't remember that video, you can watch our invisible ink video for a refresher on what hydrophobic means. But now it's time to show you how this works. So, what I have here is some oil. If you don't have oil, you can also use butter. Just be careful not to make a mess, because if it gets on the table, it will make a mess. So, I'm going to put a little bit on this paper towel, like that. And now I'm going to rub it all over my hand. And you want to be able to see the oil all over your hand. Now I'm going to take one finger that's covered in oil and one finger that's not, and I'm going to put them both in the bowl. All of a sudden I notice the finger that has oil doesn't feel as cold. And it's because it's keeping the cold water away from it. So you just put a tiny layer of oil on your finger. But penguins and other Arctic animals have it coated all over their feathers. Now that they've been in the water for a bit, let me take them out. And all of a sudden in the air, I can feel that the finger that had the oil on it is much warmer than the finger that didn't. So if you were a penguin, you would want to be covered in oil because when you get out of the water, you'd be warmer. So if you were to look at a penguin feather, they actually have a tiny bit of oil all over the feathers. Their feathers feel kind of greasy. And they're not the only bird that does this. Lots of other seabirds, birds that swim, like ducks and geese, also have a little bit of oil on their feathers. It keeps the water out and it helps them to be able to swim better. And if you're in an Arctic environment or the Antarctic environment, you really want to be able to keep that water out because that makes it harder for you to keep your body temperature up. So now you know a little bit about what specific heat capacity is. So I hope you learned something about specific heat capacity or hydrophobicity today. If you were able to correctly guess how the penguin keeps water out of its feathers, then give yourself a pat on the back. And I really hope you try and enjoy this experiment. Bye!